In this video, I will discuss differentiation of algebraic functions. Start with the derivatives of constant. Let us determine the standard formula of the derivative of constant using increment method. Considering the equation y is equals to c. Just replace y into y plus increment of y, then solve for the value of increment of y, just transpose y to the right side of the equation. Substitute the value of y which is equal to c, then combine similar terms. Increment of y therefore is equal to 0. Divide the entire equation by increment of x and establish the limit as change in x approaches 0. Therefore, the limit of increment of y over increment of x as change in x approaches 0 is equal to 0. Therefore, the derivatives of constant is equal to 0. For example, number 1, y is equals to 10. The derivatives of 10 is equal to 0 since 10 is constant. Second one, derivatives of y is equals to 1/4. Since 1/4 is constant and the derivatives of 1/4 is equal to 0, therefore the derivatives of y with respect to x is equal to 0. Number 3, y is equal to square root of 25. Square root of 25 which is also constant, so therefore the derivatives of 25 square root is equal to 0. Number 4, the derivatives of y is equals to 2 raised to negative 5. Since 2 raised to negative 5 is also a constant or a fixed value, therefore the derivatives of that which is also equal to 0. Number 5, the derivatives of y is equal to sine 60 degrees. And sine 60 degrees which is also constant with a fixed value of 0.866. So therefore the derivatives of sine 60 degrees is equal to 0. Next, y is equal to logarithm of 5 to the base 10. Since logarithm of 5 to the base 10 is also constant and the derivatives of that which is also equal to 0. Number 7, y is equal to L in E. L in E is also a constant which is equivalent to 1, so therefore derivatives of L in E is equal to 0. Number 8, y is equal to A, and A is also constant and the derivatives of A is equal to 0. Derivatives of variable. Let us also determine the standard formula of the derivatives of variable using increment method derivatives. Considering the equation y is equals to variable x, just replace y into y plus increment of y as well as the value of x into x plus increment of x. Then solve for the value of increment of y, just transpose the value of y to the right side of the equation and that is becomes negative. Substitute the value of y which is equals to x and then combine similar terms, therefore the value of increment of y is equals to increment of x. Next, divide the entire equation by increment of x, so therefore we have now the ratio of increment of y over increment of x is equals to increment of x over increment of x which is equals to 1. Establish the limit as change in x approaches 0. So therefore the limit of change in y over change in x as change in x approaches 0 is equals to 1. So therefore, the derivatives of any variable is equals to 1. For example, number 1, y is equals to t. To determine the derivatives of this given equation, derivatives of y with respect to t is equals to 1 since t is variable. Second one, y is equals to w. W is also a variable, therefore the derivatives of y with respect to w is equals to 1. 3, y is equals to r. Y is equals to r. R is also a variable, therefore the derivatives of y with respect to r is equals to 1. And y is equals to s, and s is also a variable, so therefore the derivatives of y with respect to s is equals to 1. Derivatives of constant and variable. Let us determine also the standard formula of the derivatives of constant and variable using increment method derivative. Considering the equation y is equal to cx. Just replace y into y plus increment of y and x into x plus increment of x. To solve for the value of increment of y, just transpose y to the right side of the equation and becomes negative. And substitute the value of y which is equal to cx. Then combine similar terms, then divide the entire equation by change in x. So therefore, the ratio of change in y all over change in x is equal to c. Establish the limit as change in x approaches 0. Therefore, the limit of change in y all over change in x as change in x approaches 0 is equal to c. So therefore, the derivatives of constant and variable, just copy the constant and determine the derivatives of the variable, which is equal to 1. For example, number 1, y is equals to 5x. 5 is constant and x is variable, and the derivatives of x, which is equals to 1. 5 times 1 is equals to 5. The derivatives of y with respect to x, therefore, is equals to 5. Number 2, y is equals to negative 3x. Negative 3 is constant and the derivatives of x, which is equals to 1. Negative 3 times 1 is equals to negative 3. Therefore, the derivatives of y with respect to x is equals to negative 3. Next, y is equals to 1/3 of t. 1/3 is constant and t is the variable. And the derivatives of t, which is equals to 1. So therefore, the derivatives of y with respect to t is equals to 1/3. And the last one, y is equals to 0.25s, where s is variable and the derivatives of s is equals to 1, then 1 times 0.25 is equals to 0.25. Therefore, the derivatives of y with respect to s is equals to 0.25. Next, derivatives of x raised to n. Let us also derive the standard formula of the derivatives of x raised to n using increment method derivatives. Considering the equation y is equals to x raised to n. Just replace y into y plus increment of y in x into x plus increment of x. Then solve for the value of increment of y. Just transpose y to the right side of the equation and becomes negative. Substitute the value of y, which is equals to x raised to n. Then expand the given equation, then combine similar terms. Then divide the entire equation by increment of x. Then after that, we're going to establish the limit as change in x approaches 0. Therefore, the limit as change in x approaches 0 of increment of y all over increment of x is equals to n times x raised to n minus 1. Therefore, the derivatives of x raised to n is equals to n times x raised to n minus 1. For example, number 1, y is equals to x raised to the fifth power. The exponent is 5. If we're going to subtract 1, that is now becomes 4, and copy the exponent. So therefore, the derivative is equals to 5x raised to the fourth power. The second one, which is the derivatives of y is equal to x raised to the fourth power. So we have the same procedure. The derivatives of y with respect to x is equal to just copy 4 multiplied by the base x and subtract 1 from the exponent, and that is now becomes 4x cubed. Number 3, y is equals to x raised to negative 3, and the derivatives of y with respect to x, just copy negative 3 and multiply by the base x and subtract 1 from negative 3, and that is now becomes negative 4. So therefore, the derivatives of x raised to negative 3 is negative 3x raised to negative 4. Number 4, y is equals to 3x raised to the 6th power. Just multiply 3 times 6 is equals to 18. Then subtract 1 from the exponent. Therefore, that is now becomes x raised to the 5th power. So therefore, the derivatives of 3x raised to the 6th power is 18x raised to the 5th power. Next, if you have the given equation y is equals to negative 2x raised to the third power. So we have the same procedure. The derivatives of y with respect to x, just multiply 3 times negative 2 is equals to negative 6, then subtract negative 1 from the exponent, or subtract 1 from the exponent, and that is now becomes negative 6x raised to the second power. Number 6, y is equals to 1/4 x raised to the 5th power. So we have the same procedure, just multiply 5 to 1/4, and that is now becomes 5 all over 4, and subtract 1 from the exponent becomes x raised to the 4th power. So therefore, the derivatives of 1/4 x raised to the 5th power is equals to 5 all over 4 x raised to the 4th power. And number 7, y is equals to square root of x. Just transform radical into fractional exponent, or that is equals to x raised to 1 half. So we have the same procedure to determine the derivatives of this. Derivatives of y with respect to x, therefore, just copy 1 half, then multiply by the base, subtract 1 from the exponent, or 1 half minus 1 is equals to negative 1 half. Or you can uh, make this one into positive exponent and becomes 1 all over 2x raised to 1 half, or in terms of radicals, this is 1 all over 2 a square root of x.